Let us try to master the strategy of writing equation from the given graph of any exponential function. We will see how the y-intercept and the value at 1 or 2 can help us find the equation from the graph. Thank you. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we will learn how do we connect a graph with equation. We are working with exponential functions. It is very important to relate the two things for better understanding. And this video is going to help many students who are working towards pre-calculus. Well, in case you want to learn directly from me, send an email on the address given. Here you see 4 examples. We need to write the exponential equation from the given graph. The form of equation is also given to you. As you will notice, we have gradually complicated the scenario. We began with a very basic exponential function, which is a times b to the power of x. So the parent function is being multiplied by a, which is leading to vertical stretch. The second one, we have translated C units up in this case, and in the third one, we have a graph which relates combination of the previous two, right? And the same thing we have seen in the next graph. So we're working with growing and decaying or increasing or decreasing exponential functions. Now this is a very important question from test point of view. Many times you have to match equations with the graph. However, here we'll focus on how do we write the equation from the given graph. So let's begin with the very first one. We'll also understand the strategies to do it very easily. So the very first graph given to us is exponential growth, as you can see, and we need to find the function in the form a b to the power of x. So clearly there is no translation in this particular case. The key points to look in are the y-intercept. So this key point you can read is, let me call this as a. Point A is the y-intercept. When x is 0, we have a value of 2. So if you're looking for the function f of x equals to a times b to the power of x, substituting 0, that means f of 0 equals to a times b to the power of 0, right? What do we get? Well, the value is 2, and we have a times anything to the power of 0 is 1, and therefore we do get the value of a as equal to 2. From here you understand that directly from the y-intercept, where normally it will be at 1, we can see the value of a, right? So that actually represents the value of a. I can write this as a 0a, right? So the y-intercept helps us to give us the value of a itself. So let me write down here as a note, y-intercept is key, right? Provides the value of a. Now how do we get the base b? So anything to the power of 1, you know, is the base itself, right? So the base value normally comes from the second point, which is at 1, right? So let's consider the second point, which is here 1, 6. Do you see that? So let's call this point as a b point, right? So b is 1, 6. So now we know a is 2. That means I could now write f of x as equal to 2 times b to the power of x. Is that clear to you? Substituting the values, we get 6 is equals to 2 times b to the power of 1. Anything to the power of 1 will be the same thing, right? So 6 equals to 2b, and dividing by 2, we get the value of b, which is equal to 3. So we get the b value from 1. You get the idea. So in exponential functions, these two are very, very critical points. So now we have the function. We can write down the function as f of x equals to 3 to the power of x. Makes sense. So to summarize, we found the vertical stretch from the y-intercept and the base from the value at x equals to 1. Is that clear to you, right? So at x equals to 1 gives us that value. Perfect. Let's move on now and take up the second case. In the second example, we have a vertical translation. And what is that key parameter which gives you vertical translation? Well, that is the horizontal asymptote, right? So that's the key parameter. So normally the horizontal asymptote will be along the x-axis, correct? But now we see this horizontal asymptote has moved up, right? So if I look into this particular graph, this is divided into 10 portions here. So each one is what? Each one is 2, right? Right. So the horizontal asymptote is y equals to 3. So y equals to 3 is the horizontal asymptote. In this case, y equals to 3 is the horizontal asymptote. And that gives you the value of c. So we get the value of c as equal to 3. So we can write the function f of x as equal to b to the power of x plus 3. Makes sense? Correct? Since the y-intercept is, since the horizontal asymptote is 3, right? Now, how do you find the value of b? Once again, for finding the value of b, we can now look into the key points, right? So let's look into the how far is it from the axis. We can see the y-intercept, correct? That could be a good point since there is only one unknown here, right? So this point here is 0. You can see it is 4, right? 0, 4. So let me call this point as a. Substituting the value of a, which is the coordinate point 0, 4, I could get the f of x is 4, right? When x value is 0, right? So that clearly means that the equation should have involved Now, how do you find the value of b? Well, to find the value of b, we need to take another point on the graph. The best point could be 1, right? Now, in this particular case, at 1, we do get a value which is 5. So, as you can see from here, from the graph, we have the value, this is 2, 4, 6, and just in between is the value 5. So that is the value which we could take at 1. So let me call this point as B. So B is 1 and 5. So if I substitute 1 for x and 5 for y, I could get the value of B, right? So let's write down 5 is the y value, b to the power of 1 plus 3, correct? So, which means 5 taking 3 to the left side gives me the value of b, and that is 2, right? So, value of b is 2. So, therefore, now we can write down the function f of x as equal to 2 to the power of x plus 3. So, the graph has been translated 3 units up. You get the idea. And that is how we do get this. So what we have learned now is that to find the a value, y-intercept is a good value to look into, and to find the b value, x equals to 1 is actually a good value. Now let's move on and take the next example where we are now combining all the things. So we learned how do we find the vertical stretch or compression factor, and also the translation factor. Now here is kind of a test question for you. How do we do this? Well, to find the value of c, what should you do? To find the value of c, we should look into the horizontal asymptote, and clearly, in this particular case, the horizontal asymptote is at y equals to 2. And therefore, c is equal to 2. And so I can write the function f of x as equal to a times b to the power of x plus 2. Makes sense? Now to find the value of b, I should look at the y-intercept, which is for us at minus 2, right? So let me call this point as a, which is 0, minus 2. So if I substitute the value of a, which is 0, minus 2, I will get minus 2 equals to, this is f of x, a times b to the power of 0 plus 2, right? So that means minus 2 is equal to a times 1, which is a, right? So minus 4 is the value of a. So we get the value of a from the y-intercept. Making sense, right? Things are coming together. So we can now write down our function f of x as equal to minus 4 b to the power of x plus 2, correct? To find the value of b, let's take the value at 1. So at 1, you know it's x-intercept. So let's call this point here as b, right? So let me write down this point here as b, which is at 1 we have y equals to 0. Make sense? So if I substitute this value, then f of x is 0 when the value of x is equal to 1, right? So we have 0 minus 2 equals to minus 4b, right? And that gives me the value of b as equal to minus 2 divided by minus 4, or half. Perfect. So we get the value of b as half. You see that? And therefore, I can write down my function. We got all the three values. Let me write down here. A for us is minus 4, b is half, and c is equal to 2. And therefore, the function f of x is equal to the value of a minus 4 times b is half to the power of x, and c is plus 2. Makes sense? See how easily, step by step, we could actually find the equation from the graph. So remember, horizontal asymptote relates to the vertical translation. The y-intercept relates to vertical stretch or compression, and the value at 1 helps us to find the base of exponential function, correct? I would like you to apply all this knowledge and get the equation for the next graph, which is similar to what we just did, right? So you should begin with the y-intercept with the horizontal asymptote, relating it with c, then check the value at the y-intercept and at 1, right? So at 1 we have this value, and at y-intercept we do have a value there, slightly difficult to read. Now when that is the scenario, then you might prefer to use two other good points. You get the idea. So in this case, I can see that this is a very good point, right? So now, because the y-intercept is not accurate enough to read perfect, therefore, we may have to now pick up the other points. So that's a note for you. So I'd like you to pause the video and answer this particular question. I hope all this is helping you out, but in case you want to learn directly from me, feel free to send an email on the address given. So anyway, let's begin. We know the horizontal asymptote, right? So let me write horizontal asymptote is y equals to, let's count, it is 4, right? So 1, 2, 3, 4, right? Y equals to 4 is the horizontal asymptote. So that implies that c is equal to 4, correct? So we can write f of x as equal to a b to the power of x plus 4. Makes sense. So now we have two good points to read, and I think we'll use these 2 points, right? So one of them is at 1 we have a value which is 3, right? So we'll call this point as a. So we have a point a. Let me write down here. We have a point a, which is at 1 we have 3, and the other point is b, which is the x-intercept at 3, correct? So substituting these points one by one, we get two different equations to solve, right? So here is another strategy, right? So a is 1 and 3. So I'll put 3 for y or f of x and b to the power of 1 plus 4. So that gives me 3 equals to ab plus 4, right? Or 3 minus 4 is ab or minus 1 is ab. Is that clear to you, right? So that is one. And secondly, if I put 0 and 3, in that case, x value being 3, I am getting the y value as 0. So I get 0 equals to a times b cubed, right? Hello, we are not interested. So let's put 3 here for x, and in that case we get the y value of 0. 0 equals to a times b cubed, right? Plus 4. So minus 4 is equal to ab cubed. Correct? So minus 4 is ab cubed. So we have now two equations. Perfect? So if I divide one by the other, if I divide equation 2 by equation 1, in that case, what do you get? Well, we get minus 4 divided by minus 1, right? ab cubed divided by ab, right? Which gives me 4 equals to b square. And remember, b has to be greater than 0, right? So the restrictions are b should be greater than 0 and also b is not equal to 1, correct? So because b is positive, when you do the square root here, right? In that case, we get 2 as the value of b, correct? So b is 2 for us. Since we have found the value of b, we can now substitute here. So substituting b as 3, let me say this is equation number 3 for us. We get minus 1 equals to b is 2, right? A times 2. So minus half is the value of a. Makes sense? So we have found the value of a as minus half, b as 2 and c as 4. And that gives us the equation which is f of x equals to minus half, right? A value, b is 2 to the power of x and c is 4. Do you see how we have got the equation from the graph? Look here, since it is minus half, the range of the function is less than 4. You see, it's going down, right? And it's decreasing, right? So these are a few important things to do. I would like you to again find the equation. You see at 2, we have a very good point also here, which I purposely did not take in this particular example. Since, many times we land up in situations that we do not get every good point to take. So you may have to use some strategies. Perfect? So anyway, you can use this particular point to check your answer, right? That makes sense, right? So with this, we come to an end of this excellent, very useful video, and I hope you have understood how do we find the equation from the given graph of any exponential function, right? So these are basic steps and strategies which should help you to understand the concepts better. Thanks for your valuable time and all the best.